Thank you, Nikhil. I hope I'm audible enough. Hello.
Yes, I can start.
Okay. Thank you. Thanks, Nikhil. Thanks. So I welcome everyone to the second day of this refresher course that we have designed, that we have scheduled. So yesterday, due to the lack of time, so we had to cut short this session. Then again, we have to keep in mind of the time limitations. Yes. So today again, what I'll try to do is I'll try to limit the discussion to 1 hour, and after which your respective queries can be shared in the query list. Yes. So there's a link that is being circulated, and I think maybe yesterday's queries, whatever you had, right, so those might have been like circulated again, or if not, so that will be done soon. So you should not be worried about that. All your queries have been answered, has been attained, right? But then again, the queries, just a gentle reminder to everyone, it should be specific to the session, and that to the technical queries, right? Not related to certificates or PPTs and slides. So that will be looked after by the organizers of this course. So that you need not worry. Definitely, they are keeping a very close watch of this. Okay, so you will be provided accordingly whenever it's required. So today we'll be discussing about the role of geosciences in the oil and gas industry. Because yesterday I saw a lot many few questions. I wouldn't say a lot many questions, but few questions were very much interesting as well. So people are indeed curious enough, like how geosciences disciplines, or let's say people from the geoscience backgrounds, they can find themselves suitable, or they can find their understandings or their education in the oil and gas industries. So, to be very frank, the geosciences disciplines are having multiple utilization, not in only in the oil and gas industry, but in the other sectors as well. All right. So so means you need not worry. So maybe if suppose if your interest lies in some other domains as well, so definitely the geoscience people can definitely look for the career opportunities. But then again, you also have to look for yourself as well. But then again, right, so like oil and gas industry is also having a lot many openings and opportunities from various backgrounds, from various pathways. So one can definitely look for itself, and then accordingly they can make plans. So when you're talking about geosciences, so like from the word itself, geoscience means it's a science that dealing with the earth. Yes. So what we have in this planet earth, so we are having certain natural resources. Yes, the existence of these natural resources, this is what the people from the geoscience backgrounds they do study about it. And while they're studying, or while they're analyzing and assessing those sources, or let's say those instances, or those samples, then what happens is they will be able to tell us, or they will be able to share their thoughts, or let's say they will be able to come up with certain conclusive information. What kind of resources are those? Yes, whether let's say those will be some kind of resources which are like which are some energy sources, or let's say those are some necessary water accumulations. Yes, or they can be minerals as well, right? So apart from oil and gas, we also have minerals, or let's say the mineral deposits in the subsurface, right? Then again, when it comes to certain disposal, or let's say certain disposing activities, whenever you need to dispose, let's say wastewater, yes, or let's say any kind of wastes, instead of keeping it out in the open, and then like calling in a lot many complications in the environment, so what we can do is we can take help from the geoscience people, or let's say the geologists, or let's say the geophysicists and the geochemists, whosoever might be there in the oil and gas industry. So they together, they can help us in devising a certain plan, a safe plan, yes, or let's say a functional plan, by which the wastes that are being generated in the oil and gas industry can be disposed. Then again, natural hazards, since there might be mountains nearby, yes, so landslides, or let's say erosion activities, and all those related hazards can be studied and assessed as well. Yes, so there are a lot many options. There are a lot many options. Then so like these things are mostly common in the onshore activities, or let's say these are also found in the offshore activities as well. But then again, when you're shifting towards the offshore aspects, then what you have is you have additional understanding, or let's say the additional studies of the oceans. Yes, that is the oceanography that I'm talking about. And then let's say the study of the climates, or let's say the study of the winds as well. Yes, so meteorology has to be there again, because when in offshores, that means it's a location which is very rarely visited by people on a daily basis. Yes, so and then again, it calls for a lot many challenges, as well as problems might come up when there are some rough seas, or let's say when the climate, or let's say when the weather is not so pleasant enough. Yes, so these things have to be kept in mind, right? So when you're talking about geology now, so what is geology? So geology is all about studying about the earth. Yes, and when you're talking about earth, so this will reflect, or let's say this will lead to the study on the materials that the earth is having, that is this planet is having. Yes, let's say how these formations are established, or how the formations are existing. Yes, then what were the processes that might have led to the formation of the mountains, let's say, or let's say the processes that are related or that are associated with the formation of oil and gases. Yes, let's say what factors were responsible, right? So all those favorable conditions, all those processes, or let's say the components which might have contributed towards formation of the mountains, or let's say formation of oil, formation of gases, or let's say how come water is trapped inside the subsurface formations. All there's questions, all this mysteries can be found, or can be can be unearthed by the principles of geosciences. So geology is not only about rocks, but rather it's about understanding the various systems by which we are able to understand the mysteries, or let's say all the clues are being available for us. Only then we'll be able to realize that how come we are able to retrieve, or how come we are able to reach up to a certain depth, and how come we are able to extract, or let's say recover oil and gas all the way from the subsurface. Yes, but then again, so that is just a part of it. However, so when it comes to geochemistry, yes, so geochemistry will again deal with the origin of the petroleum, or let's say origin of the hydrocarbons. Yes, or let's say the accumulation of the hydrocarbons, or let's say the migration of the hydrocarbons. Yes, and also it will also include the maturity of the hydrocarbons as well. So a lot many things comes up. Yes, but then again, because of the limitation of time, maybe it might not be feasible enough to discuss all those aspects. But then again, our efforts will be to bring out the best possible discussions and touch upon each of the topics in the best way possible. Then, so yesterday we have discussed about the life cycle, or let's say the activities that are associated in the oil and gas sector. Yes, so mostly the geosciences disciplines. Yes, so at times you can also come across this keyword, that is GNG, that is geology and geophysics. Yes, and apart from this, we also have geochemistry as well. So that is not to be excluded, that is not to be forgotten. So in the exploration phases, the geosciences disciplines, or let's say the planetary sciences disciplines, have a major role to play. Yes, because when we are in the exploration phase, what we're doing is we are finding, or we are looking out for prospects. Yes, we are looking out for locations, we are looking out for areas, or let's say certain places where there might be possible accumulations in the subsurface. Yes, because based on that, what will happen is tomorrow the drilling team would be coming there. The drilling team would be setting up their arrangements there. They will be, they will be putting up the rigs, and then they'll start drilling. So if everything turns out well, then what will happen is they'll be able to discover oil and gas from those locations. And once they start discovering oil and gas, then what they will do is gradually they will start increasing the number of wells. In what they will do is they'll be able to find out the boundary where the oil and gas is existing, or let's say the extension of the hydrocarbon fluids. And then gradually what will happen is they will start into the commercial phase, that is the in that is the development phase, whereby the commercial production of oil and gas would take place. So that is the objective of each and every exploration activities. Yes, so that's why we have this ENP process. Yes, so exploration followed by the production activities. Yes, so that is why the contributions, or let's say the participation of the geoscience discipline is very much crucial for the success of the oil and gas industry, right? So one should not forget. So what things, or let's say what are the objectives, or what are the roles that the geoscience people have to offer, right? So when you're talking about geology, so like we have already discussed in a brief, yes. So when it comes to geology, so a lot many things we're discussing, yes, out of which let's say the concept of tectonic plate movements is one of them, right? So we do for all the petroleum engineers, so like those who are not from the core geosciences disciplines, they also have to understand that how this planet Earth has formed, or let's say how the formation of a certain sedimentary layer, or let's say a sedimentary formation has occurred. Yes, what were the processes associated? Yes, so we know that, let's, if you're talking about the tectonic plates, or let's say the plate tectonics, so we know that means many million years ago, so there was a supercontinent which underwent drifting, and then it split into two continents, or let's say two land masses. And then gradually what happened was there were multiple land masses that started drifting out, and then now we have the present existence of the continents, or let's say the countries altogether. Yes, so maybe that means India, Australia, and South Africa were all together, which started drifting away, right? And then South Africa, sorry, not South Africa, but the African continent. So that took its current location. Yes, its current extension. Then India started drifting towards the Asian plate. Yes, so whereby it started colliding with the Asian plate. Yes, and then that gave rise to the mighty Himalayas, which we see. Yes, then Australia, it moved all the way towards the Pacific Ocean, as you can see, whereby you have New Zealand nearby, or the small other islands as well, right? So that is just one part, or let's say that is just one concept of geology. Yes, so apart from this, the geologists, they also look for fossils, let's say, yes, because they have to look for indications of the presence of organisms which possibly might have led or might have contributed towards the formations of hydrocarbons. Yes, so like in geology, what we're doing is we are trying to understand the processes, or let's say the occurrences, or any kind of activities that might have taken at a prior stage, or let's say at a prior date. Yes, so it's a historical study. But what we are doing is we are studying it now from the evidences, or let's say from the samples that you are able to achieve, you are able to come up with, which are available nowadays. Yes, so from this, what we try to do is we try to date back, we try to correlate what happened back then. Yes, and when you're talking about the historical dates, or let's say the historical activity, so we are referring to the million years back, by the way, not some 50 or 100 years back. We are looking into it, but then again, when it comes to oil and gas, we are going much more backwards. Yes, so it's not about 100 or 50 years that we are talking about, we are talking rather some million years back, or hundred of millions of years back. Yes, so as you can see, the plate tectonics which we discussed, right? So this is the African plate now, the current extension of the continents and the countries altogether, right? So you have lot many plates. Yes, so and then the tectonic plates are still in movements. Yes, so they have a particular, or let's say a typical direction. Yes, so as you can see, the Indian plate, so as you can see, so it is moving, or it is colliding against the Asian plate. Yes, because of which it had given rise to the Himalayan mountain ranges, right? Then again, as you can see, that Australia have moved away from India, right? And then this is where it is existing currently. Then you have the North American plate, then you have the South American plate. Yes, so now if you just look carefully, then one can also say that means if you just try to compare this part of South American continent with this part of Africa, then definitely if you just look at it, yes, in a very rough instance, then one can say that this part can easily fit here. So that means this can give rise to a lot many theories, and this has been proven as well. That means Africa and the South American continent, they once existed all together. Yes, in the same way, when India was also a part of the African continent. Yes, and then the land masses started drifting away. So these are some very very interesting and very curious things and processes that happen. Yes, and those can be only understood from the various evidences, from the various processes which have been established by the geosciences society, right? Then apart from that, we also study about the different layers of earth. Yes, so this has been a very good topic. Why? Because if I'm not wrong, that many of us have studied about the various layers of earth back from the high school days, right? So like, see now, so we have the different layers of earth now. Yes, and depending upon their extension, depending upon their thickness, so you said, you see, that means you are having the different stages, or let's say the different parts of the earth. Yes, so we have the core at the center. Yes, then what you have is you have the inner core, the outer core, right? So the current location, or let's say where we are standing right now, where we are residing currently, so that is the thinnest part of the earth. Yes, so the crust which we where we are deciding, or where we have the mountains, the seas, the oceans, yes, or where we are drilling, so that is the thinnest part of this planet earth. Yes, so if you just consider the crust with that of the, let's say, the core, or let's say the mantle, so it is much more thicker. Yes, so if you just find out, if you just Google for yourself that what is the let's say the average depth of an oil or gas well. Yes, so you'll hardly find it, it is going up to 3.5 or 4 kilometers, hardly. Yes, then again, in rarest of the rarest instances, you also have wells that have almost gone to some 11 to 12 kilometers as well, but those are very rare occurrences. Yes, so you see now, that means in order to come across, or let's say in order to like, clear this crust, then you have to drill much more deeper. Yes, which is then again not possible, because when, as you're going deep, what happens is the temperature increases, and so does the pressure. Yes, so these two things no one can control. Why? Because this is a natural phenomenon, and you know very well that no one can play with nature, no one can manipulate nature. Yes, so you don't have any icing mechanisms, or let's say some freezing mechanisms by which you'll be able to control the increasing temperature, because we have the geothermal gradient as well. Yes, so the geothermal gradient, as you go deeper and deeper, it starts increasing. Yes, so that means as we go deep, or let's say as we go deeper and deeper, the temperature increases, right? Now, when again, now when you're studying about geology now, so like there are two philosophies, or let's say there are two perspectives of how the earth has formed, right? So like one of them is the principle, or let's say the concept of catastrophism, right? So like this concept, or let's say this principle of the formation of earth, or let's say the history of earth, what means what they have come up with is that means it was being interpreted, or it was being understood in such a way that means all the all and or let's say the entire history of earth, or let's say the entire activities of earth that has taken place so far, it has started alongside with the Bible. Yes, so that means they have taken the Bible as a reference for the formation and for the existence of earth. So whatever events and activities are mentioned in Bible, that's what they have tried to interpret in terms of the real life cases, right? But then again, we have the much more actual and much more scientific approach and the concepts, which is the uniform materialism, right? So when we are talking about this catastrophism, so it is just stating that the Bible has taken, or let's say the Bible has been taken as a reference to understand, or let's say to make the people understand, or to make the society understand how the earth is formed. Yes, so if you just see, that means as per their concepts, that means as per the Bible, so the it is being said that the earth was formed, or let's say the earth was created at some 4004 BC, before Christ. And we know that what is the current year. Yes, so that is some 2022 AD. So if we just add it up, so it just comes to some 6000 years. But then again, we know very well that means dinosaurs have existed many million years back. Yes, and prior to the existence of dinosaurs, we also had some let's say the unicellular organisms as well. We had very small sized organisms as well. Yes, we didn't had mammals for a very long period of time. We didn't had birds for a very long period of time. Yes, so gradually these organisms which earlier existed, yes, so many million years back. Yes, so as you can see the time scale here where we're talking about. Yes, so this is the time scale, as you can see. So this gives rise, or let's say this makes us understand the various stages, or let's say the various time periods where these organisms, or let's say where this particular species has started to come up, or let's say has started to evolve. Yes, so we humans are are the newest addition to this long list of organisms that have survived or that have lived this earth. Yes, and so with taking into consideration of all this, so finally the conclusion comes as follows: that the earth was formed some 4.6 billion years back. Yes, so you just see the contrast now. You just see the contrast between this concept and the concept of catastrophism, which just said that the earth is some 6,000 years old, let's say, or let's say 7,000 years old. On the other hand, we are talking about something which is some 4.6, 4.5 billion years old. Yes, so there's a huge contrast between these two concepts. And finally, what happened is when things started to make some sense. Yes, when people started finding evidences of, let's say, the skeletal remains of many organisms. Yes, then people started to accept this concept, that is the uniformitarianism concept of the Earth's history. Yes, but then again, uh, there are always exceptions. Yes, as you know that in chemistry as well, there are a lot many exceptions. The same goes in life as well. Yes, so the same has been found, has been proved in many instances in the geosciences background as well. Yes, so as you can see that there are certain craters somewhere in this earth. Yes, so there are certain phenomena, there are certain locations in earth which are beyond explanations. Yes, so like that means even this concept at times it fails to prove, it fails to comprehend what has happened, or what might have been the reasons for the formation of this particular crater, let's say. Right, so a lot many things are yet to be deciphered in the most appropriate way. But then again, till the time it is deciphered, till the time a very, a very sensitized explanation is there, so people are made to believe that certain exceptions are there, and apart from that we have no other way but to accept things as they are, or as they were from the beginning. Yeah, so it's a tradition that we're following, right? Then after those perceptions of the formation of earth, or let's say the history of earth has been established, now what we do is we come down to a different classification, or let's say to a different description of understanding the events that might have taken place. So these events can be understood in two ways, or there are two approaches, let's say. All right, so what we have is, we have the relative timings, or and we have the absolute timings. So when we talk about the relative timings, or let's say when you talk about relative ages, so in such cases you don't know the specifics. That means, let's say if today if we ask, that means at what particular date a particular event that might have occurred. Yes, or let's say what is your date of birth. Yes, so we will be knowing it for sure, we will be knowing it specifically. So that comes as the absolute ages, or let's say the absolute dates. Yes, so we know the exact means information, we do have the exact knowledge and understanding that when a particular event have occurred. Yes, but then again, if we ask, that means how old is a family, let's say. Yes, that means not your family but your entire family tree. So in such cases you won't be able to come up with a certain, or let's say with an absolute information, with an absolute figure. So in such cases you definitely you have to take some relativeness. Yes, you have to compare with something else. Yes, so that is how again things are being made to understand. Right, so like if we say, that means when was the first human that might have means, that might have seen the light of the sun, that might have step foot in earth, or let's say how come they have come to the earth. Yes, so in such cases also, since there's this is still a controversy, but then again it has been established in one way or the other. Yes, so like the first mans, or let's say the Neanderthals. Right? So this is one thing that one should understand. Right, then uh, for many petroleum engineers, few of the concepts are very much necessary. Yes, out of which this particular principle of relative dating. So these principles are very much important for them, because we also have to understand what type of formations are existing in the subsurface, or let's say what kind of rocks we might be dealing with. Yes, or let's say what kind of fluids it might be dealing with, or how a particular subsurface might be looking like. Yes, so that will be again incorporated into the reservoir model, by which you will be having a full-fledged understanding of the subsurface. So when we talk about the principles of the relative dating, so the first and foremost is the principle of superposition. Yes. So the principle of superposition, what it tells is the oldest rocks, or let's say the rocks which are formed at the very beginning, so they would be at the bottom, and then comparatively newer rocks would be at the top. So so this is what the principle of superposition tells. Yes, so that means the undeformed sections of the sedimentary or the layered igneous rocks. Yes, so that means the older rocks would be at the bottom. Yes, so that means this would be the older rocks, and here you'd be having the younger rocks or the younger ages. Right. Then the second principle is the principle of original horizontality. So there's a principle, what it states is that means when there's a deposition to occur. Yes, so if this is the space that is available for deposition, so it will be happening in the horizontal orientation or direction. So it won't be a vertical deposition, rather it would be a horizontal deposition. So that is another principle, that is another concept we have to understand. Right. So these are the answers to the various instances that we get to see. Then what we have is we have the principle of cross-cutting relationships as well. So whereby we see that the younger features, or let's say the younger generation rocks, or let's say the formations, what they do is they cut across or they come across the older features. So if you see that there's a rock which is of some older age, then what you see is, if you see a different a section of rock, then definitely this is a younger feature, or let's say definitely this is a younger rock that is there. Right. So for the principle of superposition now, as you can see that this is a very basic and a very simple experiment to understand. So when you start depositing different sediments or different layers of sand, so you'll see that the first deposit layer, so that is the oldest one, followed by comparatively younger one, and then at the top you shall be having the youngest layer that would be deposited. Yes, so the youngest layer would be deposited very recently, whereas this oldest layer might have been deposited at a very earlier stage. Yes, so this is one of the understanding of the principle of superposition. Yes, so as you can see now, so this particular structure, as you can see, so there are certain distinctions here. Yes, so you can well see that means this becomes one of the section, this becomes one of the section, and this becomes another section. Right. Then again, you can also make out that this becomes another section, and finally this becomes another section. Right. So that means this particular section, whatever it might be, as you can see that this is a part of the Grand Canyon in the United States. So this is one particular formation, and this is indeed the oldest formation, or let's say this is the oldest deposited layer, whereas this particular formation or this particular layer would be the youngest layer. Yes, and all these layers which are in between the top and the bottommost layer, so those layers would be comparatively younger. Yes, so if you move from bottom to top, right? Then this picture which you see here, this reflects the principle of horizontality. So as you can see here, that means whatever deposition or whatever layers have formed or layers have deposited and then transformed into sedimentary beds, so all these have occurred in the horizontal direction. Yes, so so see these are what we should understand. Yes, so I think you won't be seeing any deposited layers which will be in the vertical orientation. Right, but then again we have deformations, we have certain geological events by which there will be folds and faults. Yes, so that's a different aspect, by the way, because right now we are just understanding the principles now. Yes, so how come the formations might have formed, and how come this might be, this might be reflected in front of us. Then the criss cutting relationship. So what we understood was the newer features will be cutting across the older features, right? So what you see here is that means, so this is one originally existing formation. Yes, which is comparatively older. Yes, than the layers which are at the top. So as you can see here now, so it is cutting through the older layer. Yeah, so these are called the cross cutting relationships. Yes, so these things are much more they're much more clearer, they are much more fascinating when you get to see it with your own eyes. Yes, but for that again there has to be certain exposures to the geological locations. Yes, so whereby the geological field trips can be conducted, and there has to be certain exposures of this particular kind of sections by which you will be able to understand, and those things will be there in your mm, in your minds. Yes, so a few things means at times it's hard to understand, or let's say it's hard to keep in mind. Yes, till the time you don't get to see it with your own eyes. Then apart from that, you also have the concepts of inclusions, whereby a piece of rock will be enclosed in another rock. Yes, so the rock containing the inclusion will be the younger rock. Yes, so this is something which is contrasting, or which is different to that of the cross-cutting relationships. Yes, then what you have is you have the unconformities, then you have the principle of fossil successions. Yes, so depending upon all these principles, depending upon on all these concepts, what we are able to understand is like lot many things might have occurred. So these are the instances, or these are the evidences how come a particular section, or let's say how come a particular formation have formed and how it is existing currently. Right, so here also if we just see, that means here so now this is reflecting this is signifying an unconformity here now. So what you see as a, this is one layer here, and then this is another layer here. Right, so so these are a few of the things that you have to understand. Right? Okay, then this is one of the what to say, I won't say it means it's not important, it's definitely important, because when you're studying about the fossils, when you're studying about the various geological samples, so we have to understand it, or we have to perceive it in terms of the geological time scale. We've seen that means earth was formed some 4.5 4.6 billion years back, right? So based on that, so what we have is we have the segmentations of the various events or the various processes in terms of the time scales. Yes, so what we have is we have the epoch, we have the periods, we have the era, and then we have the eons. Yes, and accordingly what you'll have is, based upon this you'll be having the significant events that might have taken places. Right, so as you can see, that means when did the human beings mean when did they when did they first evolve, or when did they first come to the earth. Yes, then you'll be having the age of the mammals, then you'll be having the first of flowering plants as well. So it's not only the means it's not only creatures or the animals that have that have evolved. It is also the flowers, it is also the trees that have evolved. Right, so so the geological time scale is again one very crucial concept to understand the all the processes. Yes, because in order to describe, in order to signify a particular event that might have taken in the past, definitely you have to take help of the time. Yes, only then we will be able to establish its proof of existence. Right, so that's why you see that means whenever means you might have heard, or let's say you might have come across certain literatures as well, or you might have heard people saying that this particular rock is from the let's say just the Cretaceous period. Yes, so when you're talking about Cretaceous, so definitely there's a certain time that we're talking about. Yes, so for much more clarity on this topic, so definitely you can refer out to the geological time scale. But then again, it is not necessary to understand, means to keep a note of all the events. Yes, so that means then again it's not expected as well from you all. That means you should keep a note of all the time scale, or let's say the time periods. But then again, few of the things if possible have to kept in mind, let's say the sequence as well. Yes, but then again, as you are studying, or let's say when you're in your projects, or when you are in your dissertations, or let's say in your interviews, or let's say in your work, then definitely you can keep this geological time scale handy, and then depending upon that, when someone is describing about a particular geological sample, then you will be able to have a clear-cut understanding that which particular date it is referring to, or let's say what particular time it is referring back to. Then so since we are discussing about the study of rock, study of the planet Earth, all the elements, all the natural resources that are existing, so study of rocks is also important. Yes, because it is in these rocks, it is in these formations, you shall be able to find out, let's say, minerals, yes, which might be of great use to us. Yes, then you will be having the accumulations of oil or gas or water as well. Yes, so for that you have to understand what type of rocks are available today. Yes, so it all starts with what? It all starts with the igneous rocks. Yes, so because we have the rock cycle as well, I think that will be showed in the coming slides, I don't know, right? So we have the igneous rocks, which are the result of the cooling down of the lava of the volcanic eruptions, after which what happens is, yes, so this is the rock cycle. So it all starts with the volcanic eruptions at the very beginning, right? And after that, when the magma, or let's say when the lava, it cools down, then what happens is, definitely when the temperature drops down, so it solidifies, yes, also it hardens. Then what happens is, as this hardened rock masses, or let's say the solid masses, they would be subjected to climatic changes. Yes, there would be changes in the weather as well, there would be changes in the temperatures. So as there are the changes, then what will happen is, they will start to erode. Yes, so when they start to erode, then definitely what will happen is, they will start breaking into some small fragments. Yes, so when they start breaking into small fragments or into small pieces, then what will happen is, they will start to travel, they will be transported, or they will be carried away, like say via wind, or let's say via the flow of the rivers. Yes, and then what will happen is, they'll start accumulating, or they will start depositing, or they will start settling at a certain place, or maybe the others might be again moving ahead. Yes, so gradually what will happen is, when they start getting deposited, then what will happen is, small deposited layers, then what they will do is, again they will undergo burial, they will be compacted. Yes, and then they will be held together by natural cements, or let's say natural cementing materials. Yes, and once they form, or once they satisfy all these conditions, then what happens is, they are having a binded structure. Yes, now this binding structure will depend on the intensity of burial, the intensity of the compaction that it has experienced, and the level, or let's say the intensity of the cementing activities. Yes, so depending upon that, it will be a hard bind rock, or it might be a loose bind rock as well. Yes, so that is how the sedimentary rocks form. And as the sedimentary rocks are forming, so what will happen is, all those dead plants and animals we discussed yesterday, which turns out to be kerogen at a later stage, and then eventually into individual oil and gas streams, so they will be also trapped within those sedimentary framework. So within the grains, what we'll have is, we'll be having the pore spaces, or let's say the empty spaces, within which these fluids will be accumulated and then trapped inside. That is one. Then we will be also having the metamorphic rocks. So the metamorphic rocks, in the name itself, we can understand that, so this kind of rocks are those rocks which undergoes metamorphism, or let's say changes in its existing structure, right? So under the application of pressure and temperature, then definitely there might be some alterations, or let's say modifications in a rock structure, which give rise to the metamorphic rocks. Yes, so while looking at the rock cycle, so you can well understand that how each and every rock, or let's say how each and every component is connected to each other, or let's say how come a sedimentary rock can form into a metamorphic rock. Yes, or how come an igneous rock can form a metamorphic rock. Yes, or let's say how come from a large boulder, or let's say from a large rock mass, how come there would be existence of small sediments. Yes, so for that, the rock cycle understanding is very much necessary. right? So the reason why we are studying about rocks now is because this is providing us with a chance to understand the physical properties of the individual rocks, be it the sedimentary rocks, be it the metamorphic rocks, or be it the igneous rocks. Then again, in terms of sedimentary rocks, be it the petroliferous rocks, or let's say the petroleum bearing rocks, or the non-petroliferous rocks. Yes, because from these rocks we get to understand the texture of the rocks. Yes, we get to understand the structure of the rocks, or let's say the mineral compositions, and finally the chemical compositions. Yes, so all these indications, or all these observations, this helps us in understanding what type of rocks or what type of scenarios we are dealing with. Yes, what type of strength, or let's say what type of binding capacity you are dealing with. Yes, because late at a later stage you have to drill through those formations as well. Yes, so the formations can be soft formations, or the formations can be hard formations. Yes, so depending upon the nature of the formations, so your drilling plans, or let's say the drilling activities, will be adapted as well, right? So altogether, so the means as the final outcome would be to achieve a efficient oil and gas exploration and production objective. So that is what we are looking for. Then those sedimentary rocks which will be having oil and gas accumulations, so those are also known as the reservoir rocks, right? So for the reservoir rocks, or let's say for those sedimentary rocks, then again there are further classifications. That means either the reservoirs would be some carbonate reservoirs which are formed from some chemical changes. Yes, and then there would be certain let's say there would be the sandstones which are formed from the simple sedimentation, or the deposition process, or the detrital rocks, right? So you shall be finding oil and gas either in the sandstones or in the carbonates mostly. Yes, then again, now there's a reason why we won't be able to find out in the igneous rocks. So like means you can try why we means you can try answering that in the chat box now, like why we don't find oil and gas in the igneous rocks, and again why we also don't find oil and gas in the metamorphic rocks. Yes, so you can test your knowledge by sharing your answers, by sharing your understanding in the chat box, thereby which the discussion can be carried forward again, right? Now rocks are done, geological activities are done, or let's say the historical perspective is done. Now we have to also understand the fluids which we are interested in. Yes, so the origin of the petroleum fluids is again one important aspect that the geosciences is offering us. Now this is where the geochemistry discipline plays a major role. Why? Because we are dealing with the origin of the petroleum, because now again just like the way we try to understand how old the rocks were, in the same way we also try to find out how old is that particular petroleum fluid, or let's say how old is a particular crude oil sample. Yes, so we have to find out its origin, we have to find out its maturation. Yes, so that means what is its maturation properties. Yes, so based upon its maturation, that means its thermal maturity, so its hydrocarbon composition might vary as well, right? Then again the geochemists, or let's say the people from the geochemistry background, they also study how the accumulated fluids, or how the newly formed hydrocarbon fluids might possibly have migrated from one source to the other source, right? So you see, that means just like the way from a huge boulder, or let's say from a huge piece of means a stone, or let's say a rock, how come small sediments have formed and then given rise to some different sedimentary formations. Yes, in the same way the changes in the dead plants and animals accumulation, they give rise to corrosion. Yes, and further application of pressure, temperature, and time transforms those corrosion into the liquid hydrogen, or it can be the gaseous stages as well. Yes, so for this again we have to understand the origin of petroleum then, right? Then again, depending upon its various properties or attributes, that means depending upon its density, let's say depending upon its viscosity, and depending upon a lot many other attributes, so what will happen is the color of the crude oil might also vary. So if I'm not wrong, one of the question in today's quiz was that means crude oil is normally black or something. If I'm not wrong, I was just glancing to the questions, right? So when you people were attempting it, yes. So it's not necessary that all the crude oil will be black in color, or let's say blackish in color, or let's say dark in color. Yes. So depending upon its viscosity, depending upon its density, let's say, depending upon the composition, or depending upon the various non-hydrocarbon components, the color or other properties of crude oil would also vary accordingly. And when these attributes are varying, so definitely the end result, or the crude oil which the refineries would be refining, or let's say processing, so there also there might be certain implications, there might be certain other processes that has to be followed in order to come out with an uniform product, or let's say a product which has been permitted to be sold as per the market standards. Right? So the anticline theory is one of the most common theory. The anticlines are the most common structures which we believe are existing in the subsurface, because it is in these anticlines what we find is we find the accumulations of oil and gas, right? So for this, there's a concept called as the petroleum system. So if you just look into it, then definitely there would be much more greater things to understand apart from what we're discussing since yesterday till now, right? So in this anticline, as you can see, that there might be accumulations of oil and gas alongside the water. So now the main task would be after we are done finding out the anticlines, after we are done identifying the structures, yes. So then what will happen is after means whatever activities of exploration we consider, be it the seismic exploration, be it the magnetic, be it the gravimetric, yes, then depending upon that, let's say we have established that it's an anticline structure. Now depending upon the presence of the accumulations, or depending upon the fluid levels, so the fate of the success would be decided. So as you can see here that there are 2 3 wells here now, ABC, let's say. So now you can see that these different wells are drilled in different locations and in different depths. Yes. So you have this anticline whereby there is some gas layers, there is some oil, and there's some water as well. Now if you see, that means suppose this well, if it is being drilled here up till here, then definitely it will be much more focused in the production of water. Yes, but water is something which is unnecessary for us, and that too those water which are associated with the crude oil and natural gas. Why? Because those water are not at all suitable for for any kind of use, because they are having lot many carcinogenic compounds, they are having lot many complex compounds which would take lot many processes to filter, lot many processes to break down into simpler and harmless compounds. So this is a water which we are not using it, or which is not at all required by the society, right? Then you have another well, let's say this particular well, it has drilled in this gas bearing layer. Yes, so here also we are not more we are not so focused in the gases, because when we are refining the oil and gas, or let's say when we are separating the crude oil into its various fractions, we do have the gaseous components that are coming up. Yes, and also in other aspects also, this gas cap which you see, this is a necessary driving force or a driving energy for a lot many reservoirs. Yes, so if the gas cap is completely eradicated, or it's completely it's completely pumped out, then what will happen is this reservoir which you see, it will be losing out its drive energy. Yes, or let's say the source by which this oil which you see would be pushed towards this well. So the decision on or let's say to decide on which particular locations to drill, how to drill, so that also plays a crucial role, right? So that is why it's a step by step process. Yes, so not till the time the drilling team gets a very good understanding and info, let's say a briefing from the G&G team, they won't be able to understand, they won't be able to come down to a conclusion to decide that where and when to drill a particular well. Yes, let's say if the G&G team and if the drilling team makes some mistakes which might hamper, let's say jeopardize the entire success of the project, so there would be data which might be false, which might be wrong. Yes, so if those wrong data are fed into the reservoir model, yes, so then again the entire model which is being designed, which has been built, so that will be a wrong model, or that will be a wrong interpretation of the subsurface, and based on that wrong interpretation, one might also decide a particular drillable location. Yes, and that will also end up losing all the money that the company had invested. Right. So with this, I conclude today's session now. Right. So like if you're having any query,